k in this radical equation. Root 128 plus root 18 minus root k equal to 7 root 2. Now, we're asked to find the value of k, and you can see that k is also contained in a root. Alright, so for us to simplify this, let's notice each of the roots. Root 128 is not a perfect square, so it does not have a specific root that is a whole number. But we can actually split this root such that we have at least one of the products as a perfect square. Now, if you look at this number, it's divisible by 2 because it's an even number. So we can think of a number multiplied by 2 that will give us 128. So that will give us 2 times 64 is 128 plus 18 is not a perfect square, but we can also split this such that at least one of the products will be a perfect square. 18 is an even number, so 2 can divide this, so we can also use 2 to reduce. 2 is a factor times 9. 2 times 9 is 18 minus square root of k equals to 7 root 2. So from here, notice that 64 is a perfect square, hence the square root of 64 is 8. So we can express it as 8 root 2 plus 9 is a perfect square, and the square root of 9 is 3. So this will give us 3 root 2 minus root k equal to 7 root 2. So we have succeeded in reducing this root to the simplest form. Then the next thing we do, let's try to look at the terms that addition and subtractions are possible. Now observe that here this first term contains root 2, this one also has root 2, so which means the terms are common, so addition is possible. 8 plus 3 is 11, so we have 11 root 2. They have a common root, 11 root 2 minus root k equal to 7 root 2. So from here we can see that this term and this other term this way, they are common, so we can actually bring them together because they are like. So we say we collect like terms, and since this root k is negative, so we can also transfer it this way, it becomes positive. So let's have 11 root 2, this is 7 root 2, when it comes this way it becomes minus 7 root 2 equal to minus root k becomes a positive root k. Now root 2 they are common, therefore we can subtract 7 from 11. So 11 take away 7, and that will give us 4. We have 4 root 2 equal to root k. Now from here we can now remove the roots from k because we are asked to find k, so and k is contained in the roots. So to bring this k out, we need to take the reverse of a root. The opposite of a root is a square. So we can say we square both sides. Square both sides of the equations. We square this side, you're going to be having 4 root 2 all squared equal to root k squared, so that this square will cancel this root, and each of this term we take this power, so 4 power 2 is equal to 16. Then this square will cancel the roots, so I left it 2, so we have 4 times 2 here equal to k. 16 times 2 is equal to 32, and that's equal to k. Therefore we can say k is equal to 32. So the value of k that makes this equation correct is 32. Thank you so much for watching this video.